Alright, hello everybody, my name is Javier Perez and I will be presenting the progress that our team has made thus far on Simple Feed. So for Simple Feed, we set out to develop a multi-purpose dispenser that automatically dispenses materials for the customer. And we believe that what really sets us apart from other products that are similar to ours is that it's very adaptable to what the customer needs, and so that's why I refer to dispensing material, because we envision the product being used to either dispense water or food for pets or whatever the customer may need. And as you can see here, actually, after our concept selection and concept generation phase, this is the design that we believe we will be pursuing and building in the future. A little bit on our previous work that we were able to do in our DP1 portion of the product, which was the planning phase. We were able to conduct some interviews with potential customers to see what the customers really needed from the product and what they wanted. And so we were able to generate some customer needs from these. Some of the bigger ones that we found were that the product needs to be self-sufficient. We found that the customers do not want to be tending to the product more than they would need to be their original item. For example, if they have fish, they would not want to be tending to the Simple Feed product more than they would have to the fish without it. That would just eliminate the purpose of it, really. They would also want to be able to change the amount of material that is being dispensed. For example, if you have a big plant compared to a smaller plant, you're not going to want to feed them the same amount of water, so they're going to want to have that flexibility there. And they also want to make sure that the product is safe, obviously. Next, we were able to use a functional decomposition diagram, and we iterated through some sub-functions which we were able to sort of get from our mind mapping activity. And these sub-functions are essentially smaller pieces of the whole problem of how we are going to make Simple Feed work. And so some of the most important sub-functions that we thought we needed to address are how we're going to receive input from the user. In that case, how the user is going to tell Simple Feed how much material needs to be dispensed and how often. We obviously want to make a strong support system to make sure that it's safe. We also need to figure out the dispensing method because there are many different ways that we thought about how we were going to actually dispense the material. And lastly, since we are thinking of using Simple Feed on multiple plants or animals, we need to be able to not only dispense it but then transport that material to multiple places, and so we needed to figure out how we are going to transport that material. With these sub-functions in mind, we're then able to come up with some solutions to these sub-functions. We were able to put them into a concept combination table. And as you can see here, these are the potential solutions to our sub-functions, which we identified earlier. In terms of supporting Simple Feed, we thought about using a tripod, a clamp mechanism, or an L-shaped leg to support Simple Feed. As for our dispensing method, we were thinking about using a corkscrew device which would sort of push the material along and then finally drop it off. Two offset discs with holes in the middle, which when aligned would dispense material. Or just a simple gate which would work through gravity and dispense material that way. And as far as transporting the material, we thought about using tubes or pipes. And lastly, just using a free fall mechanism where it would just fall down and we would not be able to feed multiple devices at once. And if you follow these pathways in our concept combination table, these are eventually going to be the first designs that we had for Simple Feed. And you can see those here. You can see a little bit of how the L leg would function here. You can also see the two discs with misaligned holes, which when opened would eventually allow material to fall, and then using pipes or gates to dispense the material into whatever you are trying to feed. Now, with these ideas in mind, we were able to present our ideas in a gallery method, and we were able to get some feedback from our peers on our designs, and we actually were able to get some very insightful ideas on what we can adjust to our product. Some of these are having a multiple gate system. We were a little worried about having issues with regulating how much material was dispensed accurately, and if we had a double gate system, one of them would primarily be to make sure that the material falls out, and then the second would be to make sure that it measures correctly. Secondly, we had an idea to, now with all these ideas in mind, we needed to single them down into one that we believe would be the best to move forward with. And to do that, we used some charts and a scoring system to narrow them down. And as you can see here, our selection criteria is our engineering specifications that we developed previously. And up at the top you can see the different designs that we had, with a positive sign meaning something that we believe the product excelled at, and a negative sign being something that we believe it didn't address very well. And as you can see at the bottom here, we have a total of net scores, and we decided that we were not going to continue with the tripod gate pipe or the tripod disc and pipe method at the bottom. And as you can see on the next slide, so in our final design we'll be using the double L-leg disc and tube solutions for our product. And as I mentioned earlier, the discs are 2 discs with holes in between them, and the motor is going to move and align them, and when they do align, material is going to be able to get in between them. And then there's going to be a second gate under that, which will hold the material and make sure that there's an accurate amount of material there. And once that is reached, it will then open and be able to dispense that material. We will also be using the double L-leg design. As I said earlier, we believe that it will be a lot safer and stronger than just having one. And lastly, we'll be using the tubes, as you can see here, to dispense the material into the different pathways, so you can feed multiple animals or water multiple plants. So overall, through our concept generation and concept selection phase, we were able to identify our subfunctions through our functional decomposition diagram. We were also able to use the gallery method and feedback along with the concept generation exhibits to rank our design, and we were finally able to choose a final design based with weights on the dispensing rate, dispensing time, and self-sufficiency to reach our final design, which we will be pursuing in the future. Thank you.